Dear students, good morning. Er.M.N.Ramdas. How are you? I welcome you to my channel Maths from Basics for you. So this is my class number 24. The previous classes you have learnt differentiation pertaining to sum rule, difference rule, product rule, quotient rule, composite functions, implicit functions, and today I am going to do successive differentiations. So dear students, so before I start, I remind you of my funda, learn maths from basics, and I am there to teach you maths right from basics. Dear students, I am a bit confused because I do not know whether to post short videos or long videos. If you remember, I used to post short videos earlier, which used to be hardly for 25 minutes, 28 minutes or 30 minutes, within 30 minutes. But the problem with that was, the drawback with that was, I could hardly do few problems there. So I thought, just when you started learning mathematics, that is differentiation, if I try to do 2 or 3 problems, you will be disheartened. So I thought, let me do more problems so that you will be more comfortable and you will learn more. That was the reason of me posting long videos. So I am not happy with the feedback I have been getting from you all, because you are, I hardly see the views are only hardly 70, 80, or the views picks up very gradually. But my idea is to see that everybody are benefited and everybody learn differentiation, because I am teaching with so much of pain and so much of interest. So that interest should be kept up. So dear students, so I leave to you to decide whether I have to post short videos or long videos. As an experiment, on experiment basis, I am going to do today a short video for 20-30 minutes. Let me see how you feel. Even if you want long videos, please mention the comment, or you want short videos, please mention. So accordingly, I will take classes depending upon your interest and your convenience. So dear students, without wasting your time, let's start differentiation, that is successive differentiation. Dear students, now what is successive? The word successive means what? Which happens again and again, or one after the other. So if you apply this to differentiation, we are going to differentiate this once, twice, thrice until nth derivative. So now for example, I will take here, so y equals x to the power of 9. Then just an example I am taking. If you differentiate this once, that is d by dx of y equals to what? D by dx of x to the power of d by x to the power of 9. So there is nothing but d by dx of x to the power of 9. What happens to this? This becomes 9 into x to the power of 9. So I will write this. This is our type. Type d by dx of x to the power of n. We all know this. So the solution is what? N into x to the power of n minus 1. I am doing this only for the benefit of some students who just got into my class. So this becomes what? This is n is 9 here. 9 into x to the power of 9 minus 1. That becomes what? 9x to the power of 8. So this is our answer. I will rub this, please make a note of this. Done. So what happens to this? Therefore dy by dx equals to 9 into x to the power of 8. Done. So here dy by dx is called the first derivative of y with respect to x, and this can be again differentiated because it comprises of x terms. So what happens here? If you want to differentiate once again, this can be differentiated again, because we have not got we are still of the type x to the power of n. So this can be differentiated. What happens here? To differentiate this, we write d by dx of dy by dx. So I will rub this dy by dx. So what happens here? D by dx of 9x to the power of 8. Done. So what happens to this? So again you are differentiating this. This becomes, I take this 9 outside, d by dx of x to the power of 8 minus 1. That becomes what? 9. So, sorry, this becomes 8. 8 into x to the power of 8 minus 1. That becomes what? 8 into x to the power of 7. So, this is nothing but d by dx of dy by dx is nothing but d square y by dx, which implies this is d square y by dx square. So, here d by dx of dy by dx of dy by dx is nothing but d square y by dx square. It is called the second derivative of y with respect to x, and again it can be differentiated. So likewise, as the number of terms, that is d cube to the d cube y d x cube, it can be differentiated until nth derivative. That's called nth derivative. Let's not get into that. So this now remember here d by dx of y is called first derivative of y with respect to x. D by dx of dy by dx is called second derivative of y with respect to x. Similarly, d by dx, d square y by dx square is called third derivative of y with respect to x, and so on. So finally we get what is that? Nth derivative. Let's not worry about it because it's not there in the syllabus or in this particular thing. Later when we will deal with that t to the power of n, that is nth derivative, when we get into nth derivative chapter. So this in a nutshell, try to understand that d by dx is called first derivative, d by dx of, it's also called the, for example, this is called d by dx of second derivative of y with respect to x, or second order differential coefficient of y with respect to x. Okay, I'll write it. This also called second order differential coefficient of y with respect to x. So in a nutshell I have explained to you what is successive differentiation. So this can be further differentiable. So let's not worry, we'll do some problems, we'll try to understand. So if you can understand the concept of this, it is more than enough. So we'll do some problems, it will help you, because nobody is going to ask you these things only for your benefit. I have done this. So dear students, let's stop this here and we'll get into some problems which will help you. So dear students, for example, I have taken a simple problem. Y equals to 3x to the power of 4 minus 4x to the power of 5 plus 5x to the power of 6 plus 6x to the power of 7 and plus 7. So this is a small equation, we have to differentiate it. Find, we'll say find d square y by d square x, dx square. So the moment you see this power, if it is 2, it has to be differentiated twice. If it is 3, you have to differentiate it thrice. So depending on its power, you have to differentiate it. So here it's a function of y is a function of x, so it can be differentiable. So let's differentiate this for the first time. D by dx of y equals to d by dx of 3 x to the power of 4 minus 4 x to the power of 5 plus 5 x to the power of 6 plus 6 x to the power of 7 plus 7. So here what I will do, so this becomes what? D by dx of y is nothing but dy by dx, which means to say, so now I will take this 3 outside, 3 into d by dx of x to the power of 4. To begin with, I am doing like this. Later on we will not follow all this because you have understood. Because always whenever I do, I think about a new student who is getting into the class or who is not understanding dull student. For his benefit, I am writing all this. So those who are well versed and those who are expertised in this, so don't feel bad, because for the benefit of such students I am doing this. So you a little bit just cooperate with me. So minus, I will take this 4 into d by dx of x to the power of 5 minus, plus 5 into d by dx of x to the power of 6 plus 6 into d by dx of x to the power of 7 plus d by dx of 7. So dear students, so now we have to apply differentiation for this. This is of standard form. Everything is in standard form. To begin with, I have taken small examples so that others who are just joined it, they should be able to understand this. And for first students who are just attended my class for the first time, please follow all my videos right from 1 up till 23 videos I have posted on differentiation. You will really learn a lot. So first learn that and continue, because now for freshers you will not understand this. So I request you to go back to my earlier videos and learn and come back to this, and now we can continue. Okay dear students, what happens to this? This is 3 into, this becomes 4 x to the power of 4 minus 1, that is 3 minus 4 into, this becomes 5 x to the power of 5 minus 1 is 4 plus 5 into 6. So this becomes x to the power of 6 minus 1, 5 plus 6 into 7 x to the power of 7 minus 1 is 6 plus d by d of constant is 0, since d by dx of constant equals to 0. This is a constant, so this becomes 0. So this is what 3 4s are 12 x to the power of 3 minus 4 5s are 20 x to the power of 4, 5 6s are 30 x to the power of 5, 6 7s 42 x to the power of 6. What is this? This is our d square y by dx square. So sorry, this is our dy by dx, dy by dx. Now this is your first, this is our first derivative of y with respect to x. So this can be again differentiated. This is again, this can be differentiated again. So let's differentiate this too, because he wants d square y by dx square. We'll differentiate this once again. So what I'll do, I'll rub this. I'll rub another step also. So this is dy by dx. To find d square y by dx square. So in the examination, no need to write this. Only for your reference, I am doing this. So d by dx square is what? That is d by dx of, sorry, dy by dx. So if you differentiate dy by dx once again, it becomes d square y by dx. That's the meaning. So this is nothing but d by dx of this one. So this is 12x cube minus 20 x to the power of 4 plus 30 x to the power of 5 plus 42 x to the power of 6. I write little far. 42 x to the power of 6. So what happens to this? This becomes 12 into 3 x to the power of 3 minus 1, that is 2 minus 20 into 4 x to the power of 4 minus 1 is 3 plus 30 into 5 x to the power of 5 minus 1 is 4 plus 42 into 6 x to the power of 5. I'll rub this. So this becomes what? 12 3s are 36 x to the power of 2 minus this is 20 to 4 is 80 x to the power of 4, sorry, x to the power of 3. So 20 into 4 x to the power of 3 plus 30 into 5, that is 150 x to the power of 4 plus 6 to the 12 252 x to the power of 5. Therefore, this is, I can write it, instead of writing this, I can straight away write d square y by d square y by dx square equals to this answer. So therefore, I'll write this. Therefore, d square y by dx square is equals to, this is, let me cross check this, 42 into 6, 6 2s are 12, carry ones, 6 2s are 24, plus 1 252, right. Okay, so this becomes 36 x square minus 80 x cube plus 150 x to the power of 4 plus 252 x to the power of 5. So we have found the second derivative of y with respect to x, and this is the answer. If you want, you can further differentiate this depending upon the problem that has been asked in the examination. So usually up till second order differential coefficients they'll ask you, second order, that is second derivative they'll ask you. So in the event they ask you 3 cube y by dx cube, once again you have to differentiate this. Until when? Until you don't find any x terms here. Until then you have to differentiate. It can be differentiable. So dear students, now I have taken a first example so that you have clearly understood what is successive differentiation. So it means to say you are differentiating it one after the other, again and again. Okay, dear student, one more thing I want to tell you here. See here, please make a note of this. So this is the answer. Please make a note. I'll rub this. See here, dy by dx can be represented as follows. So this is nothing but equals to y1. It can be dy by dx is nothing but, you can write dy, instead of writing dy by dx you can write y1 also, or this is also equals to what? F dash x, or this can also be written as, okay, let me not. So f dash x, and this also can be written as d this can also written as y dash. Similarly, d square y by dx square can also be written as y2, can be written as f double dash x, can also be written as y double dash, can also be written as d square y. So you can follow any of these notations while doing the problem. So depending on the problem, either will use this or will use this. Well, the problem they'll ask you, if y equals e to the power n sin inverse x, prove that 1 minus x square into y2 minus or plus whatever it is, xy1 or y2 plus m square y equals to 0. So there we'll be using these notations. So be comfortable with all these notations. So everything is same as long as you differentiate correctly. That's the main important issue. So we'll take up next problem. I'll do like this. I'll do few problems and post it. Let me see your feedback, how you like it, whether you like long videos or short videos. Depending upon the views I'm getting, I'll understand that you like short videos or long videos. Dear students, as a student I have really worked very hard, and that's the reason I've come to this, because I did my masterate in engineering and I did my masters in engineering, and today I'm here. So I want you also to be good in mathematics and teach somebody like what I'm doing to you. So I want you to impart your knowledge to others. That's the greatest noble thing you're doing on this world, in this world. So dear students, what you will learn, try to impart your knowledge to others. That is the rule of mankind. So dear students, let's do it. So dear students, this is the way they ask you questions on successive differentiation. Find the second derivative of the given function. Y equals x into sine 3x. So let's differentiate. We have to find. That means to say that we have to find d square y by dx square, because we are asked to find second derivative. Let's find it. So d by dx of y equals to d by dx of I take it x square into sine 3x. So here we have to use product rule because we have two functions. So what is product rule? Product rule, that is y of d by dx of u comma v. Done. So what we will do, we will keep u as it is and d by differentiation of second function v plus I will keep second function constant and differentiate the first function, that is d by dx of u. This is product rule. So for those who have just joined, for their benefit I have written this. So here we are going to treat this as u and v. U and v. Okay. I'll rub this. So here what happens? This is nothing but first term I'll keep as it is, differentiate the second term, that is sine 3x I keep as it is, plus I keep the second term as it is, that is sine 3x into d by dx of x square. Have you followed? So first one u as it is, differentiation of v plus v as it is, differentiation of u, that is the values, please fill it. So what happens here? So this becomes, if you differentiate that is x square into differentiate sine 3x, it becomes what is d by dx of sin ax, that is cos ax into a, whatever you have to write that. So what happens here? So a can be 3, 4, 5, whatever is the value, so write this. So this becomes cos of 3x into 3 plus sin 3x d by dx of x square. So if you differentiate x square, you get 2x. So I'll try to rearrange it. So this 3 I'll bring it here, that becomes 3x square cos 3x plus 2x I'll bring it here, this becomes sin 3x. Done. So I'll rub this. Therefore dy by dx equals to 3x square. I'll write here, okay, 3x square so we have got 3x square into cos 3x plus 2x into sin 3x. Now what he wants? He wants you to find d square y by dx square. So differentiate this once again. Now d square y by dx square equals to question mark. Okay. So I call this as equation 1. I write this for the first time. To find d square y by dx square. Differentiate equation 1, differential 1 again with respect to x, with respect to x. What happens? That is d by dx of dy by dx equals to what? What is dy by dx? Dy by dx is this. So I will write d by dx of, I will write this, that is 3x square into cos 3x plus 2x into sin 3x. So we are going to differentiate this again to obtain d square y by dx square. So what happens to this? Again we have to use product rule because we have two functions here, we have two functions here. So use product rule. So what happens to this? This becomes, I'll write here whether it will be okay. This becomes 3x square into d by dx of d by dx of cos 3x plus cos 3x into d by dx of so no, this space is not sufficient. I will write from here d square y by dx square equals to, at the bottom it's difficult. So this becomes what? First, this is the first function, and I call this as second function. So first we will apply product rule for this and again product rule for this. So first we will take this, that is d by dx of this becomes 3x square into d by dx of cos 3x plus cos 3x into d by dx of 3x square. Done. So I'll use a flower bracket so that you will not get it wrong. So plus, now we use product rule for this. So I keep this 2x into d by dx of sin 3x plus sin 3x into d by dx of 2x. And close the bracket. So I'll rub this. That is d square y by dx square equals to 3x square. D by dx of cos 3x is minus sin 3x into 3. So if you differentiate cos, it becomes minus. So minus sin 3x into 3 plus cos 3x d by dx of 3x square is 6x. So I'll use a bracket once again, not required, but anyway to show you that this is different. So here 2x into d by dx of sin 3x is cos 3x into 3. This becomes cos 3x into 3 plus sin 3x into d by dx of 2x is 2. So this becomes, I might take this minus sign outside, so this becomes minus 3x square sin 3x. So this 3 I multiply, 3 into 3 becomes 9. So 3 into 3, 9x square, minus sign is there, I take minus sign outside, sin 3x plus 6x I will take outside into cos 3x plus 2x cos 3x. So 2 into 3 is 6x cos 3x. I will take this plus 2 sin 3x. I rub this. So you have 1 cos 6x into cos 3x, you have another 6x into cos 3x, so we will add those two. So this equals to minus 9x square sin 3x plus 6x, and this becomes 12x into cos 3x, because both are same, so I have added this plus 2 sin 3x. What is this? This is nothing but, therefore d square y by dx square equals to minus 9x square sin 3x minus sin 3x plus 12x into cos x, 12x into cos 2x plus 2 sin 3x. This is the final answer. So I had told you differentiation is very simple and very easy, provided you know the formula and how to differentiate it. So I have been teaching you step by step, try to learn it. So we will go for the next problem. So dear students, we have a problem, y equals e to the power of m into sin inverse x. Prove that 1 minus x square into y2 minus xy1 minus m square y equals to 0. So here it's a simple problem and very tricky, but if you know the procedure, the method, it becomes very easy for you, but you need to remember the formulas, otherwise you cannot go ahead. So time and again I have been advising you to go through class number 1 or class number 22, because I have once again made that formulas for the benefit of you students. So please memorize it and be up to date. So let's do, without formula you can't go ahead, let's do it. So now we have to differentiate this, but since we have got y2, it means to say this problem has to be differentiated twice. So let's differentiate this. That is differentiating d by dx of y equals to d by dx of e to the power of m sine inverse of x e to the power of m sine inverse x. Okay, so let's differentiate this. What happens? d by dx of y is dy by dx. So this becomes what? dy by, if you differentiate y with respect to x, it becomes dy by dx equals to, you have to differentiate this becomes what? E to the power of m into sine inverse x into m. We know that d by dx of e to the power of ax is a into e to the power of, okay, that is e to the power of ax into a, that is equals to a into e to the power of ax. So now d by dx, because we have sine inverse x, we should know the formula for that. Sine inverse x, this is nothing but 1 by under the root 1 minus x square. So into under the root 1 minus x square. So I will rewrite this. So this is dy by dx equals to, I will bring this m on the left hand side, m into e to the power of m sine inverse x divided by under the root 1 minus x square. So what I will do, I will cross multiply. So this becomes, this goes to the left hand side, that is nothing but under the root 1 minus x square into dy by dx equals to m into e to the power of m sine inverse x. So once it goes here, now I call this as equation 1. So let's differentiate equation 1 once again. So by differentiating again, equation 1 with respect to x, what happens? Here this is a product rule, we have to apply product rule for this, we will do it. I'll rub this. I'll rub this too. D by dx of under the root 1 minus x square into dy by dx equals to d by dx of m into e to the power of m into sine inverse x. So we are going to differentiate this once again. What happens here? You have to use product rule. What is product rule? D by dx of uv. This is of the type u and v. Let us say u and v. This is of the type, because we have two functions, that is u and v. Will what is the differentiate it using product rule. What is product rule? That is, first function u I will keep as it is, differentiate the other function v, plus I will keep the other function as it is and differentiate the second function d by dx of u. Understood? So here you have to use the product rule. So I'll use it. So this becomes what? 1 minus x square as it is, d by dx of dy by dx plus keep dy by dx as it is, dy by dx second function as it is, and differentiate the first function, that is d by dx of under the root 1 minus x square. I'll rub this. So on the right hand side, I'll take this m outside. I have to differentiate this. This becomes what? E to the power of m sin inverse x into m under the root 1 minus x square. So differentiate differentiate this, and you have kept this m will be d by dx of e to the power of m into sin inverse x is same thing. You have to retain that this m will go 1 by differentiation d by dx of sin inverse x is 1 by under the root 1 minus x square. So I'll rub this. This is 1 minus x square d by dx of dy by dx square becomes what? D square by d square. This will be second derivative of y, sorry. So plus dy by dx as it is, what? D by dx of under the root 1 minus x square becomes what? So half 1 minus x square into d by dx of minus 2x, that is d by dx of minus x square, that becomes minus 2x. So on the right hand side, what happens here? M into m square into e to the power of m sin inverse x into 1 by 1 minus under the root 1 minus x square. So here next step I will write this is equals to under the root 1 minus x square. What is d square? Okay, I'll write one step. This is d square y by dx square minus into plus minus dy by dx. So this two cancels. You are left with what? We have an x by under the root 1 minus x square this equals to what? M square e to the power of m sin inverse x by under the root 1 minus x square. I call this equation 2. So what I'll do is I'll multiply equation 2 once again by under the root 1 minus x square, because I want to eliminate this under the root 1 minus x square because it doesn't require here. So let's multiply. multiply equation 2 by under the root 1 minus x square on both sides. We get what? So that is nothing but under the root 1 minus x square into under the root 1 minus x square d square y by dx square minus x, sorry, okay, dy by dx x square under the root 1 minus x square into under the root 1 minus x square equals to m square e to the power of m into sin inverse x divided by 1 minus x square into under the root 1 minus x square. What happens here? We know root x into root x is x. So under the root 1 minus x square into under the root 1 minus x square becomes, this is nothing but 1 minus x square, and what is d square by dx square is nothing but y2. I can write this as y2. Here I write, I can note here, note root x into root x equals to x, root of 1 minus x into 1 minus x equals to 1 minus x, 1 minus x square into 1 minus x square equals to 1 minus x square. That's what I have got this. Okay. So I'll remove this. Okay, now we know also d square y by dx square is equals to y2 and dy by dx equals to y1. See dear students, the second derivative of y and is the first derivative of y with respect to x. That's what I told you in the beginning. So d square is nothing but y2 and dy by dx is nothing but y1. So I'll replace this y2 minus this cancels. So I'll write this x into, what is dy by dx? Dy by dx is nothing but y1 equals to m square, this cancels into e to the power of m into sin inverse x. But what is this? What is this? This is nothing but y, because y equals e to the power of m into sin inverse x. Can I replace this by y? Yes, why not? 1 minus x square into y2 minus x y1 equals to m square y, since y equals e to the power of m into sin inverse x. You may have to put a note in your answer sheets, because though the exam knows, it's better for you to put a note. So y. So what does the examiner wants? He wants 1 minus x square into y2, 1 minus x square into y2 run. We have want 1 minus x1 y1 minus minus xy1, yes, minus x1 xy1, but he wants m square minus m square y equals 0. So bring this to the left hand side, simple. So that is equals to what? 1 minus x square 1 minus x square into y2 minus xy1 minus m square y equals to 0. So we already got it. Hence proved. So this problem may carry 5 or 6 marks. So dear students, get prepared for this. It can be asked in the examination. I know these are important problems for the examination point of view. That's the reason I have selected this problem. So dear student, we will go for the next problem. Even that is also an examination problem. So dear student, we have a problem here. This is on parametric function. So here what it says, if x equals to sin t, y equals to cos pt, prove that 1 minus x square into y2 minus xy1 minus p square into y equals to 0. It is quite similar to the similar problem, but only some difference is there. Let us work it out. This is not minus, this is plus p square by 2. So dear students, we have a problem. This is also an examination problem. So if x equals to sin t and y equals to cos pt, prove that 1 minus x square into y2 minus xy1 into y1 plus p square y equals to 0. So this is a parametric function. So let us do the problem on this. Let's do it. So very simple, it's quite similar to the previous problem. So what I'll do here, I'll use a small trick here. We have to use a small trick and try to solve this problem. Okay. Here what I'll do, first case, here x equals to sin t. So if you send this sin to the left hand side, it is not sin x into t. So this becomes sin inverse x. So this is very important. Note this. So if you send this sin x to the thing, I am sending only sin, not t. So this becomes t equals to sin inverse x. Remember this. And y equals to cos pt. So what I'll do here, I'll substitute the value of t, that is sin inverse x, in this equation. So what happens to this? Y equals to that function p into sin. T is sin inverse x. So t equals to sin inverse x and cos equals to p sin inverse x. This relation, this is given, isn't it? X equals to sin t. So I have taken t equals to sin inverse x, and since it is an important problem, I am trying to explain it once again. And y equals to cos pt. So but t equals to what? Since I write here, since t equals to sin inverse x. So what I'll do, I'll take this equation 1 and differentiate, because we want equation to differentiate any equation. Either we want y equation, that is y equals to this. Let's differentiate this y. I call this as equation 1. So by differentiating equation 1 with respect to x, what happens? So remember, this is a composite function. So dy by dx equals to if you differentiate cos, you get minus sine of p sine inverse x into p sine inverse x is under the root 1 minus x square. So what I'll do, I'll cross multiply, because I want this 1 minus x square on the left hand side. So that is here 1 minus x square into y2. So I have to bring it here, only then it is possible. So by cross multiplying, so what happens here, under the root 1 minus x square dy by dx equals to, I bring this p here, that is minus sign is there, minus p into sine of p minus x. I call this as equation 2. So what I'll do, see here, I give a hint here. After this, in the examination, if you are stuck somewhere, so what you have to do is read the problem once again. You have 1 minus x square into dy by dx, and you have already solved this. But what he wants 1 minus x square. So you might think of multiplying it once again with this. So you get 1 minus x square. But what will you do for this term, x into y1? So what you will do it, you will differentiate this. Moreover, you want d square by dx square. But here y2 means you have only dy by dx. So differentiate this once again. By differentiating once again, you will reach here. So let's differentiate equation 2 once again. I'll rub this. By differentiating equation 2 once again with respect to x, we get what? So let's differentiate this. Use product rule here. I taught you what is product rule. That is, I keep this 1 minus x square as it is, d by dx of dy by dx, plus I keep second function as it is, dy by dx into square root of 1 minus x square equals to d by dx of, I'll take this minus sign outside, so I'll take this minus sign outside, d by dx of p, I'll take p also outside, so minus p into d by dx of sine of p sine inverse x. Done. I'll rub this. I have to close the bracket, I didn't close it. Okay. So this becomes what? This is under the root 1 minus x square. dy by dx or dy by dx, it becomes d square by dx square plus dy. For here I have to add one, I forgot to add here, put here d by dx of under the root 1 minus x square. So this dy by dx of this becomes what? Half into 1 minus x square into dy by dx of minus x square. So this becomes minus 2x. On the right hand side, minus p into, I will differentiate this. So if you differentiate this, this becomes what? Cos of p sin inverse x into p sin inverse, if you differentiate, under the root 1 minus x square. I will rub this. Here this two cancels. 1 minus x square. D square y by dx square, I can write it as y2. So minus into plus, minus dy by dx is y1 under the root, we have an x here, x by 1 minus x square. So on the right hand side, I will bring this p here. So this is minus p square into cos of p sin inverse x divided by 1 minus x square. I rub this. Next step, I have to eliminate this because I want only minus xy1, but we have got x y1, we already got it, but this is there, and we have root here, but we don't want root here. Here also we don't want this under the root 1 minus x square. What we'll do is multiply both sides by under the root 1 minus x square. I call this as equation 3. I don't know whether it's 1 or 2 or 3, but anyway I'll write equation 3. If as long as you understand it, it's okay, fine. So multiply equation 3 again by under the root 1 minus x square on both sides. We get what? We get, so here 1 minus under the root, so that implies that is 1 minus x square into 1 minus x square into y2. I will want x y1, so I will interchange this x y1 by root 1 minus x square so equals to p square into cos of p sin inverse x divided by, we have divided by under the root 1 minus x square. Since you have to multiply both sides by this, I will multiply this also into under the root 1 minus x square. I will rub this. Yeah, a minus sign is there. So this minus sign I forgot. Put this minus sign. So what happens here? Root x into root x is x. So here under the root 1 minus x square into under the root 1 minus x square becomes 1 minus x square into y2 minus, here I forgot to add here, I forgot to multiply this, into 1 minus x square equals to minus p square. This is cos of p sin inverse x divided by under the root 1 minus x square into under the root 1 minus x square. So what happens here? This cancels, this cancels, this cancels. So y2 minus x1 equals to minus p square into, what is this? Cos p thing. So we have written what? You know that x equals to sin t x equals sin t or t equals to sin inverse x, but what? Y. So there is nothing but y. Because y equals to cos of pt. So therefore I have replaced it with y. But he wants what? 1 minus x square into y2 minus xy1. So I got 1 minus x square into y2. Yes, I got this. 1 minus x square into y2. Yes, I got it. Minus xy1, I got it. But on the left, but I don't have plus p square by y square. So if I bring it to the left hand side, it becomes plus. So that is becomes 1 minus x square into y2 minus x y1 plus p square, equals to 0. Hence proved. Hence proved. So dear students, this is an important problem. Please work it out once again. And what I have decided is, instead of posting a bigger videos and longer videos, I'll try to do some important problems in short videos, and I want to see the response what I get. If in the event, if you insist, let me that you want, sir, please post a long videos, definitely I'll go for my previous whatever I was doing earlier. See, one thing I want to tell you here. If you remember earlier, I used to post short videos where it is run for 15 minutes, 20 minutes, 28 minutes, maximum 30 minutes. But I used to find, we used to have only few problems. Then I could do only few problems, not more than that. And by the time you get energized or you get that interest or that motivation to do more problems, at that point of time, the video used to end at 30 minutes and used to get disappointed. Even for me also, it used to be cumbersome because I had to once again post again periodically. I have to post. So what I had planned, instead of making short videos, in the interest of you students, I thought let me make a long video and make and do more problems for you, so that you will be sit at a table, you can sit at a table and follow all my problems and work it out. So I don't know whether what I was doing earlier is correct or what I was doing now was correct. So now I have done an intermediate video where either neither a short video nor a long video. So you go through this. In the event if you find this is okay, I'll go with this, or if you want me to do short videos within 30 minutes, I'll go for that. Otherwise, like usual, like earlier, like usual, what I used to post for 3 hours, and so I'll post that. So the option is yours, the decision is yours, you decide. So based on that, I'll take a call. So dear students, let me stop at this and do, this is my part 1. So I'll do my part 2. In that I'll be doing more important problems which will be important for examination point of view. So try to follow up my videos on all my videos on post 1, part 1, part 2, part 3, etc. And we'll think about next partial differentiation. So before I end here, before I conclude, I request you to share my video, like my video and subscribe to my channel. So it's very difficult to make videos, but I'm doing it because making long video, imagine to make longer videos for 3 hours and odd, it's really cumbersome. But in your interest, for the cause of you, that I want you, each student in this world, to score well and be good in mathematics, because I know if you're good in mathematics, you'll be good in other subjects, and I want you to be a bright student for your family. If you can't be a star in the sky, be a lamp at home. That is my advice to you all. So dear students, let me stop here, and with the hope that we'll be meeting once again very shortly. So good night, take care, God bless you. Thank you.